Hi, my name is Michael from F&P Robotics, and me and my colleague Justas are happy to talk to you today about our robot Leo and how it can help during this COVID pandemic and also supporting healthcare staff and patients in many healthcare organizations in Europe. F&P is a company with 50 employees. We are based in Zurich, Switzerland, where we do our main R&D, also production of our robots, sales and services. And we also have a daughter company in Shanghai, China. We were established in 2014 and we have our background at the University of Zurich at the AI lab and also at the Bio-Inspired Robotics lab of the ETH in Zurich. We are a very interdisciplinary and international team. We have people at our company from mechanical engineering, software development, but also from psychology, health economics and neurosciences. It's a lot of combined knowledge that make our robots work well. We are operating in the area of service robotics. So robotics is mainly divided between industrial robotics and service. And within service robotics, we also distinguish between personal domestic use, where you know robots from vacuum cleaners and also toys, and for professional use, where many robots are used in agriculture, but also healthcare, operations, even in submarine tasks, and so on. So F&P Robotics is considered to be active in personal service robotics, which are professional. We have three main products that we offer to our customers. The first one is Leo, being used in healthcare. The second one is Barney, which is a fully autonomous bar, which we use in gastronomy services. And the third one, our core technology P-Rob, which is used for many different projects in R&D and industry. When we dive in a little bit into Leo, you can find three main purposes that Leo can fulfill. Firstly, it's about increasing the quality of life of people living in healthcare facilities. The second one is to increase the efficiency or to relieve care personnel during repetitive tasks. And number three is to reduce infections and improve health of the residents that are living in healthcare institutions. The last one is especially important during these current times where we all face the pandemic of COVID. So currently Leo is active in 6 healthcare institutions doing everyday duties. This is in mainly Germany and Switzerland at the moment. We focused on these markets because of language and also because of the close distance to our headquarters in Zurich so that we can do good service and support. So in these applications, Leo is taking over transport tasks, for example lab samples from different wards to the entrance, but also delivering mail, therapy tools and other items to patients and to the administrative staff. We also invest a lot in safety, so Leo complies with ISO 13482 with limited forces and limited speed, combined with the soft pads on the outer side of Leo so that it's able to interact with patients, residents and healthcare staff in a safe manner. Leo is a highly flexible and customizable system that can also work in different languages depending on your needs. Leo can learn different locations, so Leo drives through the facility and learns where he can go, where he's not allowed to go, where patients and residents' rooms are. So he's very adaptive from this location point of view. Leo provides also different interfaces depending on the IT skills of the users. So for very trained IT users, you can go quite deep, change the skills and functions of Leo on a code base. On the second level, we offer users like nurses or healthcare staff can train and also plan Leo for a week, similar to an Outlook calendar where Leo looks at and then starts. The third level of interaction with Leo is very easy. So you have some icons on a tablet that you can press to start and stop different functions of Leo. For example, giving a bottle of water to the user or telling the weather situation at the location. What is very important for being successful with robots at healthcare institutions is to focus a lot on the user needs and user experience. So in our team we have 3 psychologists working very closely with the end user on how to implement the robot, how to use it, and most important, how we can improve in such a way that the user easily can interact and use the robots. So we do a lot of user-centric studies, surveying how the robots are used, where people have problems, how to use the robot, whether the interaction mode are sufficient or where we need to improve. Leo is a Swiss made. We assemble the robot here in Zurich, Switzerland, and ship it internationally. We can also maintain and update Leo remotely. So with the current customers, we do have a connection to our robot where we can help if there is some problem, or also install updates on certain features. All the Leos are also running now during this COVID pandemic, so they are still used without any interruptions of their daily routines. We can observe them from here and, if needed, make adjustments to them. Leo is also a very customizable system, like I mentioned, so if you have different needs from a user perspective or the situation changes, we can introduce new functions very fast. During this COVID pandemic, we also proved this flexibility by introducing new features, how Leo can support healthcare staff and also patients during these very complicated times. One of the new features is detection of thermal images and also high temperature of patients and guests in healthcare facilities. A section is hygiene and disinfection, so Leo can disinfect door handles, door rails, and other items which might be contaminated with COVID-19. And a third function is delivering items, water, medicine, food to a patient's rooms which is in quarantine. So these functions we consider to be very useful during these COVID times, and Justinas will tell you more about the details of these functions.
As Michael has mentioned, we're actively working on various methods to help out during the COVID-19 pandemic. First, one of them is disinfection of the rooms and various items in the healthcare institutions. So there are a couple of robots focusing on full room disinfection, but instead we actually decided to first focus on disinfecting commonly touched items in healthcare institutions. One of those is door handles, as well as various buttons like light switches and elevator buttons. And this is done in collaboration with other Swiss partners focusing on manufacturing of highly effective UVC lights, which are capable of killing 99.99% of germs and viruses. So we developed a custom holder with a UVC light for Leo that can be easily attached or taken off from the robot. And the robot goes around the healthcare institution, placing this UVC light on top of the door handles, buttons, and other commonly touched objects for a certain amount of time that ensures an effective disinfection. And also during the disinfection process, the Leo gives warning signs to indicate that disinfection is in progress and warn people to actually keep the safe distance from the robot so they don't get any unnecessary exposure to the UVC light. Another important aspect in fighting the COVID-19 crisis is early detection of possibly infected people. And one of the early indications of infected people is elevated body temperature. We're developing a special attachment for Leo that contains a color and thermal camera so that Leo can actually, during the normal operation, observe the people that are passing by and try to measure if they might have increased body temperature compared to the normal one. And if a person with elevated body temperature is detected, then a message is sent to healthcare staff to actually confirm that by measuring the temperature with a medical device, for example, an approved infrared thermometer. Ideally, Leo can do that in the corridors or, for example, at the entrance of the clinic. And the best part is that for the UVC disinfection as well as elevated body temperature detection, Leo can do all these tasks in parallel to the normal operation of the robot. So, for example, disinfection can be done during nighttime when normally Leo is charging and idling. Also, in order to reduce the contact between staff and patients, Leo is capable of doing various delivery tasks, so bringing items to the patients who might be infected, for example, or even during normal operation just to reduce the contact. The robot is not only capable of going to various places around the clinic, but also opening the doors and approaching people and hand the items over to them. So by using our special technology of sensor fingers, the robot knows when the item is taken by the person. One of the possible use cases is, for example, water distribution, because people have to stay hydrated, and sometimes, especially for example with dementia patients, they have to be constantly reminded to drink water. With the specially designed cup holders on Leo's back, Leo can actually transport cups of water or water bottles, and in regular intervals actually hand them over to certain patients. Also, there are multiple ways to interact with Leo. So normally we can use touch by touching, for example, the fingers of the robot or press on the head. But now this is not a suitable way to do it with the risk of the infection. So also the communication can be fully done using voice commands. So a person can give answers to Leo or give the instructions, and the robot will understand the intentions of the people and perform the actions. Also, using the speakers embedded in the robot, the Leo robot can talk back to people and explain the procedures, tell what is happening, and by using the subtitles on the screen embedded in the front of the robot, various visualizations can be shown, as well as the text that is being said, for example, if people have trouble hearing. Furthermore, Leo can actually identify people by using a sophisticated face recognition software. And this allows for more personal interaction between the robot and the patient. And by using face recognition, some functionality can be enabled when Leo robot is interacting with certain people, for example, a member of staff, compared to general people passing by or patients. Our skeleton tracking system allows the robot to actually lead physical exercises, so keep the patients active. So the robot demonstrates the exercise that needs to be done, and then while the person is doing the exercise, the person can track the progress, encourage them, and count the number of repetitions that are being done. And by recording all of this data, the progress can be kept over long periods of time. All of these functions are made possible thanks to a complex hardware design of the robot. When creating Leo, FNP Robotics was actually thinking about the usability, use cases, and the environment that the robot will be operating in. Leo is made of the two main parts, so the robot arm and mobile platform. Mobile platform has all the sensors needed for autonomous navigation with enough redundancy to make sure it operates safely even if some sensors malfunction. So these include laser rangefinders, ultrasonic sensors, and mechanical bumpers, which are quite similar to the ones that you might find on the domestic robotic vacuum cleaners. Also, there are 4 cameras embedded in various parts of the robot, and that allows Leo to see the surroundings and even sense the depth from the robot to certain objects. With the microphone and speakers, the bidirectional voice interaction is possible. and also some entertainment functions like telling a story or even playing music. And all of the data processing is done on 4 computing units included in the robot itself, and that ensures that for the majority of the tasks we actually don't need to send any data outside the robot, and that helps in regards of privacy and complying with the GDPR rules. Also, with the friendly appearance of the Leo robot, the user acceptance was quite high among both the healthcare institution staff and the patients in those institutions. Leo can operate on many different levels, starting from remote controlling the robot to a fully autonomous operation. This is based on the decision engine, which actually allows Leo to take decisions depending on its current location, status, and what is happening in the surrounding environment. It takes into consideration all the conditions and finds the actions that are the most appropriate at the given moment. Also, with the interfaces that allow you to add calendar events for executing various Leo functions, this can be overridden in order to schedule Leo to perform certain tasks at the given time slots on certain dates. So just like you create meetings on your online calendar, in very similar manner you can execute various actions for the robot. Currently we have a number of robots deployed in healthcare institutions. And since the COVID-19 pandemic started, they have been operating autonomously, and with our updates sent over the internet, a new behavior has been added and adapted for the given conditions. For example, we did remove the functionality for handshakes to reduce the contact needed between people and the robot. And we're also adapting for the new COVID-19 specific use cases that we described earlier. So I hope that gave you a nice overview of our professional personal robot Leo and its capabilities, and also how we try to adapt it for the COVID-19 pandemic. And if you are interested and would like to find out more about the robot or see some videos or get in touch with us, please visit our website or use the contact details listed here, and we look forward to talking to you. Thank you.